Okay, so let's do an example. Let's graph a sine function, but we want it to be y equals sine 2x minus pi plus 3. So this would be some translations, multiple translations and dilations from the parent function. Remember that the sine function is a curve starting at 0, 0, ending at 2 pi. So that's a standard position for a sine function. So the trick, in my opinion, in graphing this type of a graph is to figure out all the dilations first. So the dilations on a trig function are a and p. But in order to find p, we have to take the standard period and divide it by whatever our b value is. And we want the absolute b. But we don't have a b value. Remember that the trig function for graphing, or the standard function for graphing a trig graph, is a times whatever the trig function is. In this case, it's sine, b times x minus h plus k. And if you notice, we don't have a b in the right position. We have what appears to be a b because it's 2 times x, but b actually belongs out front. Otherwise, we'll have to make an adjustment for h, and I don't really like doing that. I like to solve it for the simplest form that I can use for graphing. So I'm going to rewrite this function then. I'm going to write sine, and I'm going to factor that 2 out. 2 times x minus pi over 2. And notice, even though I created a fraction, which seems like, scary, it's not really, because I went from the angle pi to the angle pi over 2. That's pretty easy to deal with. So now I have a function I can work with, and I can figure out my period. 2 pi divided by 2. So my period now is pi. My amplitude, a, in this case, is just 1, so there won't be a change on the amplitude. So that means we're looking at a function that starts at 0, 0, ends at pi, because that's the period for this function, and our amplitude is 1. So we know that the point, well, let's divide this up. Dividing right in half will take me to where the function crosses the x-axis, or the angle axis. So this would be pi over 2. And because the amplitude hasn't changed, I know the elevation is 1. Halfway between 0 and pi over 2 is pi over 4, or 45 degrees, and 1. So that's a point. And then on the other side, halfway between pi over 2 and pi, is 3 pi over 4, and negative 1. So I have points that I can use in the point translation method to figure out the translations. So what happens here and what happens here. Now sometimes we can just do it in our head. It's not that big a deal. I know that 0 is going to go forward pi over 2 units and up 3. So that first point will end up there. The pi over 4 and 1 will go forward pi over 2 units, which takes us here, and then up 3, which would take me to 4. And I could do that point by point. I think it's just as easy to go ahead and write it out and use the point translation method. So we know that for our graph, the sine, let's say y equals sine of 2x, right? So all we're doing is we're looking at amplitude and period, which is the dilations on the graph. If I look at that function, I have points 0, 0, pi over 4, 1, pi over 2, 0. These ones are going to be the easy ones. 3 pi over 4, and negative 1, and pi 0. So that's a lot of points. The points that are going to be the trickiest are going to be pi over 4, 1, and 3 pi over 4, negative 1. These are easy to move forward pi over 2 units and up 3 units. So let's just look first at what happens on the phase shift. So the phase shift is I'm going to go positive pi over 2 units. So I'm going to add pi over 2 to whatever is already my x ordinate. So x is the first ordinate, so I've got pi over 2. This point is going to move forward pi over 2. This point will move pi over 4 plus pi over 2. Might need a little scratch work. So that's 2 pi plus pi over 4, 3 pi over 4. And you may not have to do scratch work. I'm just showing you that it's as easy to do as it's not. Just to put it in there. I already saw, and you already saw, that if I started at pi over 4 and I moved forward pi over 2 units, I'd end up at 3 pi over 4. So 3 pi over 4 and 1. Pi over 2 plus pi over 2 takes me to pi, 0. 3 pi over 4 plus pi over 2 takes me to 3, 4, 5 pi over 4. I'm going to show you that arithmetically too. If I start at 3 pi over 4 and I move forward pi over 2 units, I'm going to add a common denominator to this one. So I have 3 pi, or I'm going to create a common denominator, which means I'm going to multiply the pi over 2, the numerator of pi over 2, by 2 over 4. And so 3 plus 2 is 5 pi over 4. So if you can't see it on the graph, no worries. It's just a quick calculation. No big deal. And then pi plus pi over 2. Well, what is pi plus pi over 2? If I start here and I go forward pi over 2 units, where am I? Well, pi is 1, 2 pi over 2 units, plus 1 more is 3 pi over 2. Using just a different logic to help build the concept. All right, so now all I've done is done one of the shifts. I've done a phase shift. All I have left to do is raise the y ordinate by 3. That is totally easy. So I'm going to add 3 to my y ordinate. So I have pi over 2. 0 plus 3 is 3. 3 pi over 4. 1 plus 3 is 4. Pi. 0 plus 3 is 3. 5 pi over 4. Negative 1 plus 3 is 2. And 3 pi over 2. 0 plus 3 is 3. So now when I want to graph this, right? Well, I know that I'm raising the x-axis, or the center, the line that bisects in a horizontal bisection my function. I'm raising that middle line up 3 units. So I could say, I could just dot that in and see that I've got y equals 3. And then the forward action is going to be to go to pi over 2. So pi over 2, and I can dot that in. And now if I just sketch the same curve, all I have to do is put in my values. Okay, so if this is pi over 2, I know that the 3 points on the x-axis become pi and 3. So this is at pi and y equals 3. This last point, 3 pi over 2. And now all I have to do is plot these 2 points, which were super easy to calculate. 3 pi over 4, which would be here, but I'm going to do it as a point. 3 pi over 4, and I went up to 4, raised to 4, and then this point is 5 pi over 4, and raised only up to 2. So that is the graph of a sine function with 1 dilation and 2 translations.